Okay, so now, because the penalty costs are uncertain, because C out is uncertain, we have to use our probability model, which is we have to know the probability distribution for C out. And as we discussed last time, we're going to assume a very simple distribution. So in our model, the probability distribution function for P, for the function of C out, is simply like this. Okay? Which means C out is lying between some range of C min. So let's call this to be C low, or C min. And let's call this to be C max. Okay? So we know that C out, and that again is fairly reasonable. That you may not know C out exactly, but you will likely know the range. And if there are a number of possible reasons why C out could change, then the most likely distribution actually will be Gaussian. In reality, it will look like this is the most likely distribution. Okay? This is what you would really get, but we are not. But for analysis, we are going to assume this. Okay? Simply because otherwise the integration becomes a mess. Okay? So we are not going to assume Gaussian. Okay, so if you assume this, then it's actually pretty straightforward. We know that the area under this rectangle has to be what? 1. So therefore we know the height. So the height simply has to be 1 divided by C max minus C.
What is it? I didn't understand that last class. I understand the bottom.
Sorry, what?
I don't understand how you know the height is that difference.
Area equals base times height. The base
Because the area is this times this.
True.
The product is 1, so this has to be 1 divided by this distance.
True.
Yeah, makes sense? All right, good. So now, of course, we want to now figure out our total cost. Okay? And we want to figure out the most likely, most probable total cost. Because total cost is uncertain, right? So we're going to do the most likely total cost. So to do that, remember what we do is we figure out the expression for total cost and you integrate it over all probability distribution. So first let's look at the cost for scrubbing.
Shaman,
Yeah.
how do you get that line again? The 1 over C max minus C min?
Because the area of this rectangle doesn't look like a rectangle, but I can make it bigger.
Should that be a square?
No. Square root b of the two are equal. Sorry, why should it be a square?
I thought it was like the area should be 1.
The area is 1, why would that make it a square?
Because of the area is length times width, so if the going up is C max 1 over C.
It's not square, I mean you can make it square, it doesn't matter because the two have different units, so you can make it whatever shape you want. It all depends on what units you assign to it. Sorry?
I said it's supposed to be quadrilateral. Let's not get too excited.
No, I'm saying you can make it a square because it doesn't matter because the units are different.
You can make it a hexagon.
So it depends on whatever units you choose. But yeah, so no, with the magnitude of this times the magnitude of this distance must be 1, right? So this must, do I need to write it or is it okay?
Can you write it?
So this probability P times C max minus P min equals to 1. Right?
Gotcha.
This is the P value here. Okay? Okay, so now let's look at the most likely cost. So let's first look at the scrubbing cost. So the scrubbing cost is alpha over C out minus delta C. Right? So that's the cost of scrubbing. But we don't know C out, so what we're going to do is we're going to integrate this over the probability distribution function of C out. Which means we're going to multiply this by the probability P of C out and integrate over dC out. And we're going to integrate it over the entire range, which means from Cmax to Cmin. Okay?
Why not Cmin to Cmax?
Yeah.
Oh, I'm sorry, Cmin to Cmax. Yeah. Okay? So that's the most likely cost of your scrubbing operation. Now, of course, you have to add the most likely cost for the penalty. The penalty is this constant beta times C out minus delta C minus C save. And again, you multiply the probability of C out, DC out. Now, what would be the range here? Sorry? Well, in principle, you're right, but we already said that this penalty function is 0. The only condition is that. So Ci minus delta C must be greater than Cs. So C out must be greater than Cs plus delta C. Right? So you only have to do Cs plus delta C. C max. Right? Because otherwise the penalty is 0. So yeah, the limit would be Cmin to Cmax, but except in the rest of the region, the penalty is 0, so you don't have to count that. Right? So this is a total cost, most likely total cost. Make sense? Yeah.
Well, I'm just saying, in actual industry, would they just make CS a smaller number so that when they calculate it to be safe, because usually penalties are much higher than operating costs?
Well, you don't know. That's the whole point of this operation. Numbers are also expensive. Right? So it all depends on, I don't know. So, yeah. Now, of course, I'm giving you an example. Now, the same mathematics might apply to a lot of different problems. Now, we all know that companies don't necessarily try to design them to be safe enough so that they're below a lot of limits. What's a classic example that is exactly the opposite? Volkswagen. You guys don't know Volkswagen's story? What did Volkswagen do? Sorry?
They lied? Is that the company that lied?
They did worse than that. What did they do?
They faked their data?
They didn't entirely test the fake data. They did something very interesting. They designed the car so that it will respond differently under test conditions compared to normal conditions. So if you're taking it for a test, it basically, it doesn't give your engine as much power, so you're not going to be able to go as fast, but everything will be, the exhaust will be very good. But in normal driving conditions, it will allow you to put more power, and we all know when the engine has to provide more power, it's less efficient. So in reality, it was polluting, although in test, it will show that the car was not polluting. The car will perform really well, so the people buying it like it, because they like driving the car, because it has a ton of power. That's what they did. So yeah, they lied, but it was worse than lying. I mean, I don't even know what category you would place it under. The only reason this company did not go bankrupt is why? Because it is the biggest car manufacturer in the world. It actually was bigger than Toyota last year or the year before that. And so they have enough resources that they can survive this. Otherwise, most of the companies would have just gone under. So yeah, companies don't always do what is necessarily the safe limit. If they would do an analysis like this, they'll figure out, okay, how do we maximize the returns? Is that right or wrong? I don't know. You might argue, well, the society should impose such high penalty that the optimization will tell you that don't be unsafe, right? So if beta goes to infinity, what will happen? You know what the solution will be.
Negative.
So, no, if Cs goes to beta goes to infinity, you will say, well, design the scrubber so that we never have to pay penalties. That means set C naught, C out to be C max, and design delta C to be C max minus Cs. Or a little bit more than that. Why?
Just in case.
Because the scrubber also has inherent uncertainty, right? The performance of in the scrubber is also uncertain. Put a safety factor in there, and then put twice on top of that, just so that you never ever have to do that. Yeah.
Don't realistically you could like alter the black box on the left to make sure that in the worst case should happen, you can just reduce production a little bit or something?
But the problem is usually, well, no, you would never do that. Shutdown of a big company is the absolute worst thing you can do. not even the shutdown, taking it to an unsteady state mode is as bad as shutdown. You don't want to change variables because then you go from the count. You want everything to operate nicely at all set points, steady state. When you certainly have to change something, it's the cascading effect. God knows what that will do. Shutdown and startups are very dangerous things. So yeah, you certainly don't want to do that. But in reality, you could also say, you could say something slightly different. You could say, why not put an outlet sensor that will tell you what the ammonia concentration is and change the flow rate of the scrubbing liquid accordingly. So basically do an online control. And you can certainly do that because they are online sensors, but that's not the assumption we are making right now. Okay? By the way, you also need this kind of a system in hog houses. Because hogs produce so much ammonia that you actually need a scrubber just to clean the air coming out of the exhaust of a hog house. At least in Europe, I don't know about America. But these scrubbers are really nice. These scrubbers are like back of a truck. And that's exactly what it is. Just a truck. Move it there, you connect the exhaust to the inlet, you have a nice spray system for nitric acid, everything is done. And you have exhaust and you're all done.
Can you use the ammonia as like
You can, I mean, you are using ammonia in some sense because the ammonia that is coming out, basically on this scrubber, basically ammonium sulfate, which is the fertilizer. You could potentially use it, yes. But the cost that you are incurring to do it is basically higher than the actual cost of selling the product. Because you're working with very low ammonia concentrations, right? Okay, all right, so the rest of it actually is fairly straightforward. And so I'm going to, oh wow, we have 3 modes. But how do I use it? I can't. Because I need this expression.
If you want to erase the top, you can push that up, pull that one down, and erase it.